Hello, my name is Muhammad HABIBIE and I am from Indonesia.
Hello, my name is HAIDAR and I'm from Indonesia.
Hi guys, my name is SHABRINA SAKRONI and I'm from Indonesia.
Halo, Assalamualaikum warahmatullahi wabarakatuh. My name is SHEBANI. I am 19 years old and I'm from Libya.
Hey everyone.
Hello, I'm Henry MESHACK from ODONGO and I come from Kenya.
So I'm gonna answer for question number 1. The question is we have to show the value of AL for each line of this code, and I already wrote the code in Visual Studio. First, I will build the project, then moving on to local Windows debugger. In this line, we move this binary to AL and we do an instructions which we compare this binary with the previous one. 1 and 1 is 1, 0 and 0 is 0, 0 and 1 is 0, and so on. And the final result, we have this binary value which is equal to 1 in hexadecimal. If we step into, so AL equals to 1 in hexadecimal. In this line, we do the same as before because this is an instructions. We compare this value 12 with 3b. We convert it to binary form. So 0 and 1 is 0, 1, 1 is 1, 0, 0 is 0, and so on. So we have this binary which is equal to 12 in hexadecimal. If we step into AL equals to 12 in hexadecimal. This is different from the previous instructions because this is for instructions. We will compare this binary with this value in hexadecimal. First, we have to convert into binary form. After that, we compare 1 and 0 is 1, 1, 1 is 1, 1, 0 is 1, 1, 0 is 1, and so on. So we have the final value in hexadecimal is 7F. If you're going to step into, we have 7F in watch 1. And the last instruction is sort. We will compare this hexadecimal with 26. We convert to binary form. Then we will compare 1 and 0 is 1, 1, 1 is 0, 0, 1 is 1, and so on. So we have this binary which is equal to A5 in hexadecimal. As you know, sort instruction performs a Boolean exclusive OR operation between each pair of matching into operands. So AL is equal to A5 in hexadecimal. Maybe that's all from me, and thank you.
Hello, my name is SALSABILA and I will explain about question 2 in Map 5. First of all, I will share screen. Then you will see our code for question 2, and this is the question. We must write instructor in assembly language code that A jumps to label L1 if either bit 4, 5, or 6 is set in the PL register. B jumps to label L1 if bits 4, 5, and 6 are all set in the PL register. C jumps to label L2 if AL has an even parity. D jumps to label L3 if EAX is negative, and E jumps to label L4 if the expression is greater than 0. So we have tried to make the code our group, then we can get this one for question 2 part A, question 2 part B, question 2 part C, and question 2 part D. Also question 2 part E, and we have to write L1, L2, L3, and L4. Then we will try. We can start to local Windows debugger. Then in here, we can see how the program will run. First, we will see which part of question 2 in the output will ask about which part we will test, and I will try number 2 or part B. Then the EAX will value 2. Then they will go to this one, and it will be in question 2 part B. So if in question 2 part B, we can see if jumps to label L1 if bit 4, 5, and 6 are all set in the label in the PL register. So it means it will jump to L1. We can see. Yeah, so this code will jump to L1. Then it will get exit, and in the output we can see the right will be jumped to L1. That's all. And it will continue for the other question if you want to try. And thank you.
Hello everyone, my name is ABDULRAHMAN AHMED RAFAT, and I'll be running the demo for FAIQ Part C question 2. Okay, so let's start right away. I'll test every case in question 2. So starting with case A, in this one, as you can see here, I already jumped to label L1, and next we will run another test case for we will test part B. Type 2, and correctly also jump to label 1. So now we will run another one for part C, which is 3, and also jump to label 2. Finally, 2 more test cases for part B and D and E. These 4, and it also jump to label 3 successfully. And last but not least, we'll test part B, equal to 5, and also successfully jump to label 4. Okay, thank you so much.
Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my name is ABDULLAH SHEBANI, and today I'll be explaining our answer for question 3, part A in lab 5. Okay, so here's the answer. Here's the code here. So as you can see here, we compare EAX with 20. So in the question, EAX is given the value of 25. So when we debug here, what the code does is that it compares the value of EAX at 20. So if EAX is greater, then we jump to loop 1. If it's not greater, if it's less than 20, then we jump to loop 2. So in our case, it will jump to loop 1 because the value of EAX is greater. So what we do, what the code does here is that then moves the value of 1 to the register EBX, as you can see here, and then it jumps to the label out in order to ignore other parts of the code, which is the second loop here, so it doesn't obstruct the purpose of this code. And then that's it. We jump to the label out, and yeah, that's the end of the code. Okay, thank you.
Hi, I'm Henry, and we are going to explain why the JMP OUTT here, why the jump, just for easier explanation, I'll refer to it as jump out. So I'm going to explain why the jump out instruction is needed for this code segment. So basically, JMP is a conditional instruction, meaning that a process of jumping will continue only if certain conditions are met. So as you can see in this program, it has 2 different conditions in which the result will depend on the operation chosen. So whether EAX will be greater than 25 or EAX will be less than 25. So we have JMP OUTT, which does the process of jumping to label out, which is this one. So and it only does that once one of the conditions in this section of the code is met. And so the question now is, what happens if JMP OUTT, if this was not included in the code, in the program? So basically, it means that it may cause obstruction to the other conditions and codes inside the program. The JMP OUTT, as you can see here, ensures that the jump is fulfilled as intended to avoid issues with the other instructions within the program. And basically, that's my understanding, and I hope you understood my explanation. Thank you for listening.
All right, let's continue to question 4. So here we are tasked to complete the 3 procedure, which is these 3. Now, this 3 has the same functions of the procedures, but this one has using loop, which means we're going to use loop here. This one is going to use decimal with jump if not equal. This one also use decimal with jump if ECX equals 0. Now we go to the code. As you can see here, this is the code. So here is using loop from here to here, and then from here to here for jump if not equal, and here to here for jump if ECX equals 0. So after we run for the first code, we will call read that, which means it wants to read the value. So we enter 5 here. So 1 plus 2 plus 3 plus 4 plus 5 equals to 15, or F in hexadecimal. So let's go to the first one. Set the X to 0. And then we add EX with ECX. ECX is the counter, and the counter is what we inputted. For example, we input 5 here, which means it starts from 5. Now, how ECX or counter works is that it decreases for each loop. So when it goes to one loop, as you see on the top right, it becomes 4. Now, it adds EX with that number. So it means we are doing what is instructed here is 1 plus 2 plus until n. So here, the result would be F. F is equal to 15. Let me show you here. As you can see in the bottom left in the watch, the EX is now 15. Now we return, which means we return to the main procedure and continue to using DEC GNE or jump if not equal. So we go to this one, we set EX back to 0, and then we set EBX to 0. So EBX here is used for the calculation, because here we can only use compare with the ECX, which means the ECX cannot be changed because it's the input. Now we increase EBX by 1 because we want to add from 1, not from 0. And then we add EX by the value of EBX, which means we add 1 first. And then it will compare EBX, which was increased by 1. As you see on the top right, EBX is now 1. It's not equals to 5 yet. So if it's not equal, as you see, jump if not equal. So if EBX is not equal to ECX, it will jump to the level back. If it is equal, it will proceed to return. So we'll repeat. As you see, EBX increases, it adds the EX, and until 5, it will become F. It compares EBX with ECX, and then it is correct, so it is equal, so it will not jump to the back, so it will just continue to the return and continue to the next one, which is using that JECXZ jump, which means jump if ECX equals to 0. So again, we use the same way as the first one, which is the loop one. So here we set EX to 0, and then we add EX with ECX as seen before in the loop, and then we manually decrease ECX by 1 because we don't use loop here. Then it will jump to done only if it is 0 because it is getting decreased by 1. But if it's not, it will continue here and it will jump to the label back. And it will go on until ECX is around 0 here. And then because it is equal to 0, it will jump into done, which means it returns. And that's pretty much the code. So here we go, using loop 15, using decimals GNE 15, and using JECXZ 15, which is the correct result. Here, the millisecond use is the how much time it took for it to process. Because I'm using the debugging, it took this long, and that's pretty much it. Thank you very much. So for this lab session, we are able to understand more about Boolean and comparison instructions, conditional jump, defining and using procedures. We also were given an example of how to do this lab, for example, and then we also were able to finish the lab works itself. So hopefully it will be able to help us more in the future. It will help us a lot, especially because assembly language in some point will be very useful for us in our career as programmers, to understand more about computers, also comparison instructions such as AND, OR, XOR, test, and not, which is pretty much what we've learned before in digital logic. There's also conditional jump, jump if specific flag values is equals to 1 or equals to 0. There's also jump based on equality between operands, or for example, JCXD is like the value of ECX and CX. And then there's also jumps based on comparisons of unsigned operands and signed operands. Procedures, return also, which is tied to procedure. And that's pretty much it. Thank you very much for watching our video. Hopefully we can see you again in the future.